Hi everyone, this is a course on how to put together a minting site. So this is going to specifically look at doing this in Next.js, but a lot of this will be also applicable for a pure React site. And I'm going to focus purely on the technical aspects of how to do this. So it's not going to look pretty, but you'll have a very good understanding at the end of this course on how a minting site is put together, how to talk to a smart contract, get your tokens minted, and update that site to show the token data if that's what you want to do. For a good user experience, the first thing you're going to want to do is test to see if they have MetaMask installed. And I'm presuming you're doing a minting site for either Ethereum or Polygon. So I have Safari here and I don't have MetaMask installed, so it's going to tell me install MetaMask. But if I switch to a browser that supports MetaMask, the Brave browser or Chrome, then I've installed MetaMask, and now it's happy that MetaMask is installed, but MetaMask defaults to the Ethereum network, and I'm going to be using the test network, Rinkeby. So I'm testing for that and telling the user to switch to the Rinkeby network. Of course, when you go live, you're going to want to switch this to Ethereum or Polygon, and I'll show you how to do that. That's a one-line change. So now if I go into MetaMask and I click on this drop down here, these are all the networks I have available. So if I choose Rinkeby, then now it's happier, but I still have to connect my wallet. So if I click on the connect button here, that will get MetaMask to bring up the connection dialog. And if I click on connect, then now it shows me the minting page. And as you can see, I've already minted 8 tokens, and I have this mint button here, so I can click on mint. It grays out the button, so I can't keep clicking the mint button, which is a good practice. Then if I scroll down a bit and confirm, and then I wait patiently for a few seconds. So as you see, my total minted went up to 9, and my new tokens data gets added to the list. So that's about the most basic but reasonably user-friendly mint site that I could think of. So let's get started. Right, the first thing you're going to want to have installed is Node. So go to nodejs.org and download Node for your operating system. Make sure you install that. And the other thing that you will need is an editor. If you want to follow along here, recommend installing Visual Studio Code. So go to code.visualstudio.com, download and install that, and then you should be ready to go. Okay, so open Visual Studio Code, and then if you go to File and Open Folder, and I'm just going to create a folder on my desktop, and I'm just going to call it Tutorials. Click Create, and then open that Tutorials folder. And then if we open the terminal by going to Terminal, New Terminal, and at the terminal you want to type npx create next-app, and then the name of the app you want to create. So I'm going to call this Next.js-Mint. So hit enter. So as you can see, it's created this Next.js-Mint folder, and we're actually going to want to go into that folder and reopen it in Visual Studio Code. So if we do cd Next.js-mint, hit enter, and then if you do code space period -r, and the -r, all that does is reuse this Visual Studio Code window, so it will essentially open the folder in this same window. So if we hit enter, there you go, we've just opened the Next.js-mint folder, and now we're just showing the contents of that folder. So if we open the terminal again, and if you do an npm run dev, hit enter, and we can command or control click this localhost 3000, and you can see we have the Next.js default starter project. You can see that this is live. If we go back to Visual Studio, open up the pages folder, click on index.js, and this is the line that we can see here. If we put some exclamations on the end and Command S to save, come back here, and we can see that it's live updating the web page. So you get a very nice experience with Next.js in that you can live code the website and see the changes immediately, which is very nice. Now I don't actually want all this boilerplate code, so let's just collapse main, collapse footer, and I'm just going to delete them like so. Save, and we have a blank page now. So I'll just change the title to say our mint site. I'll copy that and just make the description the same. Because I'm going to focus on the technical aspects of a mint site, I'm going to leave quite a few things unfinished as far as icons and things, but that's something you should remember to do, is obviously swap out all the favicons for what's appropriate for your site. Right, I'm going to create a div here and a header, and I'm just going to say minting now. I save that, switch back, you can see that immediately appears. Going to do a h2, say total minted, and we'll put a variable in there at some point, but I'll just put a 1 in there for the moment, and I'll create a button. Again, I'll want to be able to disable the button, but for the moment I'll just say false, and I want to handle the on-click event and say mint button, like so. So let's call our mint function, which we haven't created yet, and let's create that up here. So I'll create an async arrow function, and for the moment I'll just console log out minting. Let's go back here, let's bring up our console, click mint, and we're running that arrow function correctly. Let's firstly check to see if MetaMask is installed. So I am going to create a boolean called install with a setter, set install, and I'll use React use state, so it's a reactive boolean variable. And let's import use state from React. And at the same time I'll import use effect as well, because I will be using use effect. But now what I can do is I can come down here just above the return, and I can say something like if install, then return a header that says install MetaMask. And so if I default it to true, come back here, it will say install MetaMask. If I default it to false, it doesn't show. So now we want to set install dependent on whether MetaMask is installed or not. And we want to do this once when the web page opens, so that's a good use of use effect. If we set up use effect like this with an empty array sent to it, then it will just run once when the page loads. Now, how do we check if MetaMask is installed? Well, that's very simple. We can just see if window.ethereum is set. So let's look for window.ethereum, and basically I'm saying not window.ethereum. So if window.ethereum is null, then exclamation null will be true, and that's basically saying install MetaMask, because we will actually want this window.ethereum object to be set, which will happen if MetaMask is installed. So if we save, of course this browser has MetaMask installed, but let's go to Safari, and Safari does not have MetaMask installed, and so it's saying install MetaMask. So that's our first test done. Okay, for everything else we can only go ahead if MetaMask is installed. So we'll put this in an if and say if window.ethereum, and we'll put all the rest of our code inside here. So the next thing we want to test is to see if we are on the correct network. So how do we do that? Well, we can use window.ethereum.request and pass in method net version. Let's console log that out and see what that does. So this is complaining about a non-async function, so we just have to put async in front of our arrow function here for that to be happier. There you go. So I've just spelled window.ethereum wrong here, so let's just get that right. And yes, now we've got our net version number. So 4 is the Rinkeby network, so we should be on the Rinkeby test network. If I change this to Ethereum and then do a refresh, You can see that Ethereum is 1. I happen to know that Polygon is 137. So you'd want to test for 137 if you wanted to do a Polygon minting site, but we're just going to deal with Rinkeby for this tutorial. So as you can see, there is a problem here. So if I click on here and I change to Rinkeby, I don't get any refresh. So I'm on Rinkeby now and it would be happy, but if I change to Ethereum, it should say, it should update and it should say you're not on the correct network now. So how do we fix that? Well, we need to look out for the chain changed event. So let's do that now. So if we do window.ethereum.on and this actually changed. It used to be network changed, but the new way of doing it is chain changed. But network changed does still work, but you'll get a complaint that it's been deprecated. So let's use the new one, and we get this network version back, and let's console log it out. So if we save that, and in fact what I'll do is I'll just, so we can tell it differently from our other console.log, let's just say chain changed in there, like so. So now if this is the one from our initial check, and then if we switch to Rinkeby test network, we say chain changed, but you see that it's a little bit strange in that it's sending back R4 in hexadecimal. And so if I refresh, you know, we're getting R4 as decimal here, but chain changed is basically sending us back the network version but in hexadecimal. So we need to be aware of that. It's simple enough to sort. What we can do is something along the lines of network version, and I'm just going to use parse int to convert our network version to decimal, like so. You can put (10) in here, but it's not necessary. It will default to base 10. So we want another reactive variable, so let's create one, and we'll call this network, and it's false if it's the wrong network. So here I could do something simple like set network and I could check that network version is equal to 4. And I've got to be a little bit careful here. If I do a triple equals, let's see what happens there. Well, first of all, we need to add our test down here. So I'm just going to copy this because it's going to be pretty similar. but instead of install, I'm checking for not network. If the network's not the one I want, then I will just say wrong network. Save that. So it's saying wrong network. Let's switch it to the correct network, Rinkeby. Do a refresh. And it is 4, but it's still saying wrong network. And the reason why that is because network version is actually coming back as a string. So I would have to test for a string here like so, and then it's happier. Or I can keep it as a number and just do a double equals, and that's happy as well. You can do either way. I think I'll just stick to the double equals approach. And then I can do a similar thing here. So I will just do set network and see if it's equal to 4 here. Now let's see if this works. So if I switch to Ethereum, it says wrong network. If I switch back to Rinkeby, and that's happy doing that switch. So this is fine, but as you can see, I've got 4 here, I've got 4 here. It's not really good to have magic numbers strewn all around your code. And also this is something that's probably going to want to be changed. So like I say, if you want to switch to Polygon being the correct network, then this will be 137. So you don't really want to be going through your code trying to find all the 4s and changing them to 137s. Or if you want to go live on, say, Ethereum, then you want to change this 4 to a 1. So we want this in a place that's nice and easy to change, perhaps even when we're deployed on a website. So the way we can do that is we can use an environmental variable. So if we right click in here and do new file, Next.js is nice because it's got support for environmental variables sort of out of the box, which is fantastic. So all we need to do is create this .env.local file and put any environmental variables we want set up in here, and they're available to us in code. So I'm going to call this next public underscore net underscore version is equal to 4. So why didn't I just call it net underscore version? Well, Next.js is just trying to save you from yourself a little bit here. It forces you to name any environmental variables that are available on the front end, i.e. viewable by anyone who wants to hack your code a bit. They basically force you to put a next underscore public underscore in front, just to make you aware that everyone can see this. So you do have to have this. If this is an environmental variable you're going to be viewing on the front end, which is exactly what we're going to be doing. But we don't care if people can see this, is fine. It's not a secret. And so now, instead of having these hard-coded 4s in here, we can do process.env.next underscore public underscore net version, like so. And let's copy that and change that there as well. And I'm pretty sure we have to restart our dev server. So come down here into the terminal, Control C to kill the dev server and start it back up again with an npm run dev. Do a refresh. Looks like it's happy. But let's test it. So let's say we want to go live. So we now want that if we switch to the Ethereum mainnet, that it's happy and not on wrong network. So let's do that. Let's test my theory that we do have to restart the dev server. So if I just save that, come back here and refresh, yes, it's not happy. But if I Control C and do another npm run dev, and then Command R to refresh, and now it's happy with 1 as our net version. So it's as simple as that to switch between the networks that you want to be the correct network. And when you deploy, and Next.js is normally deployed to Vercel, that's the easiest place to put it, because it's Vercel are the people that create Next.js, so they support it on their platform nicely. You can set up the environmental variables in your Vercel console, and you set them up there, and you can change them there. Again, you probably need to redeploy to restart the server, but at least it's nice and easy to change those variables when you're running live. Okay, let's change it back to Rinkeby. Restart the server. Okay, so the next thing we're going to want to implement is the connect button. So the user coming to your site should always interact to connect their wallet. You shouldn't do that for them. That should be something that they kick off. So let's implement that now. So I'm going to set up a reactive variable called account, and this is actually going to start off as null. So how do we test to see if the wallet is connected? Well, we have on our window.ethereum object a selected address, and that will only become valid when the user has connected their wallet. So I'm going to come down here and copy that line there, but instead of network I want to test for account, and I know I want to extend this a bit, so I need to wrap it in a single JSX element, and I want to say here connect your wallet, and in here I will put in our button and just say connect, like so. I am connected at the moment, so let's disconnect. So if I click on here, click there and disconnect, and then refresh, that's great. I get connect wallet, but of course connect is not rigged up yet, so let me fix that. So I want to handle the on-click event, and I'm just going to do a one-liner here, one-liner arrow function, and this is window.ethereum.request, and I'm going to send it a method of ETH underscore request accounts. Let's save that. And let's see if that works. So if we click on the connect button, we get connect with MetaMask. And you can see why it's kind of called request accounts, because it's sort of saying select the accounts you want to use on this site. So I've just got the one here, so I will just do next and connect. And if I refresh, then it's happy, but of course that's not a very good user experience. So let's fix that now. Let's go back and disconnect. So again, we want to look for an event so that when you connect your account, we don't have to refresh the page to be notified of that connection. So let's do window.ethereum.on, and this time it is accounts changed. And we'll get back a list of accounts. And let's just actually have a look and see what that looks like by console logging it out. So if I click on connect, next, connect, and as you can see, we get back an array of accounts. So we just have the one account in there, but as you saw from that MetaMask dialog, we could select multiple ones, and that's why it's an array. And the current account is always the first in the array. So we could do set account and set it to the first account in the array. The other way of doing this is just do what we're doing down here, which is this. I think they're identical. I'm not entirely sure, but they seem to do pretty well the same thing. So we'll stick with that. And let's see if that works. And in fact, what we can do to see if it's identical, we'll just do we'll console log it out like that. So if I disconnect, it's null, and the array is null, so yeah, that looks good. If we click connect, next, connect, and that's the first item in the array, and that is the window.ethereum.selected address. So my feeling is it's a little bit easier to use this because we don't have to check to see if accounts is a zero length array, etc. So this just keeps things nice and simple. Okay, so now we're getting to the fun part. So we've eventually got to our mint button, which doesn't do anything at the moment, sadly, just console logs out minting. So yeah, let's start getting into the interesting stuff now. So I am going to create a new folder, and I'm going to call it utils, and inside this folder I'm going to create a new file called contract_utils.js. Now there's various libraries that you can use to make life a little bit simpler for yourself as far as talking to contracts, etc. So I'm going to use Ethers in this project. Ethers is quite a nice modern library, so we need to bring that in. So if we Control C to stop our dev server and do an npm install ethers, and I'll start up the dev server again, and I'm going to import ethers from ethers. So let's create our mint function. So export async function, and I'm going to call this mint on contract. Any function that calls a contract, I just like to stick on contract on the end, otherwise I get a bit confused about what functions are calling contracts and what are just dealing with things locally. So that's just me, and I want to put this all in a try catch because things can definitely go awry when dealing with smart contracts, so you definitely want to do a bit of error handling here. So I'll just catch and console log out the error, but of course you'll probably want to handle that on the front end and at least display something, but we won't go into that because that will just make the video very long. Right, so the first thing we need is a provider, and we get a provider by calling new ethers dot providers dot web 3 provider, and funnily enough we're using window.ethereum using MetaMask. Now the next thing we need is a signer, and we get that by calling provider dot get signer. We need this because the mint updates the contract, so you definitely need a signer to do that. Next thing we're going to need is a contract object. So we do new ethers dot contract. Now we need a contract address, so I'm going to leave that blank for the moment. We're going to need the ABI, which is like the definition of the interface for the contract, so I'm going to leave that blank for the moment, and we're going to need to pass in our signer, which we have got, but we haven't got these first two things. Now, just like changing the network version, we're going to want to be able to update our contract address just in case we need to redeploy another contract or whatever. Good idea to have this as an environmental variable. So we can do process.env dot next underscore public, because again this is readable on our front end, contract address, and let's put that in our env.local file. So I have handily provided a contract that's mintable on the Rinkeby network. Let me paste that address in here. So that's the contract address that we're going to be using for testing out our minting site. So we have our contract address, but we do still need our contract ABI. So again, I have one already set up. So the contract at this address has an ABI, of course, and I'll show you a little bit about that later, but for the moment let's just gloss over that, and I will just drop in some JSON into our project, mytoken.json, which is when you create your contract you can get this file. And let's just have a look in here. As you can see, we have an ABI property in this JSON, which we can pull in. So how do we do that? Well, we can just import the JSON nice and easy by doing from mytoken.json like so, and then now we can use this and just do mytoken dot and that property I just showed you, ABI. So that is pretty nice and simple for setting up our contract. But like I say, I'll go over some of those things I glossed over a little bit later. What's the next thing we need? Well, actually we need to specify the address we want to mint to. So that is the signer. So we can just do signer dot get address, and that will get the signer's address. And now at long last we are ready to call our mint function on our contract. So we can do contract dot safe mint, and it takes one parameter, which is our address that we're minting to. Let's await the result of that transaction by doing a result await tx.wait, and then we can return our result if we're going to use it. I don't think we use it in this particular case, but that's fine. And actually, if you want to see what these things look like, we can do a console.log. We can log the TX and we can log the result, just so that we can see something going on in our console. Okay, we've updated our environmental variables, so we should restart our dev server. And actually you can see it tells you, it's shot by, but it tells you, let's just zoom up, that it loaded env from env.local. So that's kind of handy. It tells us that. Okay, so we want to call this mint on contract from our mint button. So let's go back to index.js. Let's import mint on contract from utils / contract utils, like so. Let's go down to our mint method, and now we can do let result equals await mint on contract. Let's save that. Come back here, let's clear that. Let's click on our mint button. So it tells us we're calling safe mint. If we come down here, let's double check we're on the Rinkeby test network so it doesn't cost us anything. Well, it does, it actually costs us in fake ETH, but I do have some fake ETH in this account. So let's confirm. And as you can see, we got our transaction back, and we could actually look up this hash and see its progress, and then hopefully in a few seconds we'll see the result come back. And there you go, we got our result back, and status 1 is a happy status. Let's look this up. So if we click on View on Block Explorer, we can see that that transaction was successful. It was done 55 seconds ago. And we can actually have a look at our contract. In fact, we can see that we did mint a token, token ID 9. So it was a happy mint. And we can click on our contract, and we can see that we did a safe mint 1 minute ago. And these are some mints I did earlier. Okay, that's all well and good, but we can't really see on our front end any sort of feedback about what we minted and how many's been minted, etc. So let's just add that final bit of functionality. So the first thing that's going to be nice to do is disable our mint button while the mint's progressing, so that they can't keep hitting the mint button and queuing up lots of mints. Let's do mint disabled, and we'll default to false, but we'll use that down here. We have this disabled property here, so we'll set that to mint disabled. It shouldn't be disabled yet, but if say I defaulted that to true, you can see it disables it here. And the easiest thing to do is just, when we click, we disable the button, and when we come out the bottom, we'll set it back to false. Okay, so the next thing we want to do is show the total minted, and we'll get that directly from the contract. So I'm going to do total minted, set total minted, and that will default to 0. And if you remember rightly, we had total minted down here, and we can set that to total minted, so that will display 0 for the moment. Now, to keep things tidy, I'm going to do another use effect down here and call an asynchronous arrow function, and I want to call this whenever account or network changes, and I only want to run this code if we have a valid account and we're on the correct network. And I'll just console log out that we're getting some token information from the contract. Let's go to contract utils and export an async function that we can call total minted, again on contract, so I know this is calling the contract. And I can copy these 3 lines here. But because we're only reading the contract, we don't actually need a signer. And what you can do is, instead of supplying signer here, we can just supply provider, and that's fine for reading a contract. And then I want to get the total from the contract, and I have a method called total minted. Let's console log that out and let's return it. So if we go back to index.js, we can do let total equal to await total minted on contract. And let's just do that for the moment. But we do need to bring it in up here, like so. And let's do a refresh. So as you see, it's getting called, but it is returning this big number. So it's passing back in this underscore hex property 0x0a, which is 10 in decimal. So we need to do a little bit of a conversion here. So if we come down here, we can do let total decimal equal pass int, and let's read in total underscore hex. And then let's set total minted to that. And let's see how that does. There you go, we've got our 10 here. Now what we'll actually find is we'll want to call this also when we've minted. So we kind of want to put this in its own separate function. So let's just do that now. And we'll call it refresh because we actually want to do a little bit more here as well. Let's just copy this code here, cut that out of there, put it in here, and then we can do await refresh here, like so, and we can also do an await refresh here as well. And in fact, instead of awaiting this, we actually just want to put it here and only set mint back to enabled when we've got the new mint count. So that should work better. Let's try that. So total minted 12. Click on mint. Click confirm. And as you can see, that now got updated nicely. So the final thing we want to do is list all our tokens down here. The NFT contract that I've done is a purely on-chain contract, so we don't have to go away and find any images or anything like that. Actually, all the data is inside the token itself, which means that we can display that information down here. So let's do that bit of code next. So if we come back into contract utils, let's create an asynchronous function, and we're going to call this token URI, again on contract, and we pass it a token ID. So we can copy these first couple of lines here, like so. So this particular contract passes back a data URI, and so we can do await contract dot token URI, pass in the token ID like so. So if you want to see what this token URI looks like, let's just console log it out like so. And in refresh, well, actually first let's import the function. So this was token URI on contract, and let's just call token URI on contract with, say, token ID 1. And let's see what that looks like. So as you can see, we get this kind of weird base 64 sort of hieroglyphs back, because we need to do a little bit of work to convert this back from base 64. So let's do that now. So we can use buffer from to do the conversion for us. We only want to convert a little bit of the string, so we want to skip over the first 29 characters. We can send in this base 64 parameter to tell us that we essentially want to decode the base 64 encoding. And let me console log that out to show you what that looks like once we've decoded that. And let me just comment. Well, actually I'll leave that in so you can see what it's doing. So this is it decoded, and the substring 29 is jumping over all the way up to here, and so it's actually this little bit at the end here that's base 64 encoded. And if you want proof of that, what we can do is, if I just copy that, and if I do base 64 decode can actually just paste it in here like so, decode, and there you go. I'm not going to go into any detail about why it's all encoded in base64, etc., and why we're sending it back like that, but there's just one way of putting the data on chain. Right, so as you saw, this JSON is actually valid JSON, and we can convert that to a JSON object by doing JSON parse JSON like so, and then we can return that result. We can delete those now. And if we just wanted that first one, so first token like that, console log and look at the name property of that object, and console log that out, and as you can see, that name property is that there. But we don't just want the first token, we want all 13. So what we can do is let tokens equal an empty array. Then we can do a for loop. Like so. Reading each token in and pushing it onto that array. We can delete all that now. And of course we do need a reactive parameter to put those in. So let's create one up here. Token data. That's going to default to an empty array. And we can come down here and set token data to tokens. So now we have a token data array, and we can come down here, and after here let's do an unordered list, i.e. a bullet point, and we can do token data.map, and we'll do some list items and display the name like so. You find that in React, if you do things like this, you need to specify a key, and we can just simply set that to the index and that'll be happy. And so if you haven't used map before, map is just a really handy way of going through an array of objects, and it will pass back each object, and also you can do an optional index parameter, so you get the index as well, and it's just a very handy way of building out a whole load of list item elements like so. So if we save that and we come back here, we can see now that we have all our tokens listed here. This is pulling the data directly off each token. Let's mint another one just for a laugh. So if we click on mint, click confirm, hopefully we should get number 13 minted on the end here, and that should go up to 14 because we're starting at 0. So there you go, we've got our 13th one on the end, and we've minted a total of 14. Okay, so I did promise to tell you how I got this mytoken.json and a little bit about the contract, so let's just quickly go over that. So there's a very handy site called remix.ethereum.org, and it's brilliant for putting together smart contracts very quickly and deploying them. It might not be the best way of doing it, but it's certainly a sort of quick and fast way of doing things. And so I've created the contract here. It's called mytoken.sol. And this is a very basic NFT smart contract based on ERC 721. I've added a few other things, just a lot of it's just to be able to do on-chain data. So as you can see, this is the data that we've got back, and it's being encoded using base 64 here, and that's why we had to decode it. The only other thing really that I added is this total minted, which is a very easy way of getting back the total minted by sending back the current token ID counter, which gets incremented every time you mint, and this is a very standard safe mint method as well. So we call all these, so safe mint, we call that, go back to here, that's that method there. Total minted, that's that method there. Token URI, that's that method there, and you can see that it does take in a token ID. This one does take an address, and so we had to pass in the address here. So a reasonably straightforward contract. And then when you compile, so you can come down here and you can compile, and if you come back up here you can actually expand the artifacts folder, and this is where you get the JSON file, and that's the JSON file that has the ABI property that you need, well, that Ethers needs to interact with your contract. You can also deploy the contract directly from within remix.ethereum. It would default to JavaScript VM London, which is kind of like a built-in testnet. So that's very handy for just testing whether your contracts work, but that doesn't actually deploy it on a proper blockchain. You will need to select injected Web3. As you can see, the tooltip here says MetaMask or similar provider. So you can select injected Web3. Then you can simply come down here, make sure you select the right contract. I always forget to do this. So click on that, and then click deploy. And if you confirm that, it would actually deploy the contract for you. And then you can find the address of the contract, and this is what I did to get this address here. Hopefully you found that useful as a kind of overview of the technical aspects of creating a minting site, and thanks for watching.